Hi everyone, today we're going to be talking about exponential functions, and so far we've only been dealing with linear functions, so the fact that we are able to get to see a new type of function is really exciting. Before we dive into exponential functions, something that will be useful to us is talking about exponent rules. So the first one that we want to look at is the product rule. Now, before I give you the general rule, let's look at some examples. So the first one, we have h squared times h to the sixth power. Now, if I were to expand that out, that's essentially the first part is h times h, because that's h squared, and then I'm basically multiplying that with h times h times h times h times h times h. So there are 6 of those h's. And in total, hopefully you notice all I'm doing is multiplying a total of 8 h's. And so what this will simplify to is h to the 8th power. So that would be our final simplified answer for that one. Now let's see if we can't simplify this next one that looks a little bit more complicated. Multiplication is nice because we can rearrange the order of it and we'll still get the same answer. So I'm going to rewrite this as negative 2 times 7 times a squared times a cubed times b times b. And so if we were to simplify that, negative 2 times 7 is negative 14. And if we have 2 a's and 3 a's, and if we multiply all of those together, in total we're going to have 5 a's. And then b times b is just going to be b squared. So that would be our final simplified answer for that one. So now we can talk about the general rule. So if I have a number of x's and I'm multiplying that by b number of x's, in other words, I'm multiplying x to the a power times x to the b power, then that is equivalent to x to the a plus b power. So basically, the product rule just says that we add the exponents together. Okay, now let's talk about the power rule. So here we have x squared cubed, and if I were to rewrite that, that would look like x squared times x squared times x squared. Since we're cubing it or raising it to the power of 3, then there will be 3 identical sets of those. So x squared times x squared times x squared. And now that we have learned the product rule in the previous example, we know that when we multiply something like this, we just add the exponents together. So this would come out to x to the power of 2 plus 2 plus 2, which is equal to x to the 6th power. Okay, and then let's work with the next one. So if I expanded that first thing, that would be negative 2m to the 5th power times negative 2m to the 5th power times m cubed. And if I rewrote that, that would be negative 2 times negative 2 times m to the 5th power times m to the 5th power times m cubed. Now, if I were to simplify that, negative 2 times negative 2 is 4. And then here we would just add all of the exponents together using the product rule. And so we'd get m to the 13th power. Like that. All right, let's move on to the quotient rule. So the quotient rule applies when we are dividing different things. So we want to simplify 27x to the 5th power divided by 42x. And note here that we also want to simplify the numeric values, not just the variables. So if I wrote 27 over 42, I could rewrite that part. Let me erase that. So I can rewrite 27 over 42 into its factors. So 27 is equivalent to 9 times 3, and 42 is equivalent to 14 times 3. And I'm going to write out the x to the 5th power. And then I just have one x on the bottom. So hopefully you know from simplifying just numeric fractions that if you factor it out into its factors, you can divide. So, notice that this 3 will divide with this 3. And so we're just left with 9 over 14. And that can't be simplified any further since 9 splits into 3 times 3 and 14 splits into 7 times 2. So 9 over 14 is a reduced fraction. But notice that we did that with the 3's, and we can actually do the same thing with the x's. So this x will divide with this x. And so if I rewrite that out, we'll have 9, and then we have 4 x's in the numerator, and we divided all of the x's in the denominator, so we're just left with 14. So that would be our simplified answer for that one. Okay, so this next one we have to combine a few rules. Remember that if we have the power rule, that tells us that we would multiply the exponents together. So y squared is the same thing as y to the power of 2 times 2, which is 4. And then we have y divided by 4 in the denominator as well. Since we have the same value divided by the same value, hopefully you have a sense that that is going to simplify down to 1. So that one would just be 1. So in general, if we have x to the a power divided by x to the b power, this is going to be x to the a minus b power. So we would subtract the exponents. Okay. So now we're going to talk about the negative exponent rule. We are asked to simplify negative 5 times x to the negative 2 power. Usually these problems just want us to simplify it so that there are no negative exponents and we're only dealing with positive exponents. So I have negative 5. Notice that the negative 2 exponent is only being applied to the x value. And the way that we get rid of the negative component is we put it in, because it's in the numerator, if we bring it down to the denominator, that makes the exponent positive. So that is the simplified version of that. Let's simplify the next example. It says 4k squared divided by 8k to the 5th power. So we know that 4 divided by 8 will simplify to 1/2. And then here we would subtract the exponents just like we would normally using the quotient rule. So 2 minus 5 is negative 3. So our exponent would be k to the negative 3rd power. And remember, because it's negative right now, we want to bring it down to the denominator to make it positive. So that would be 1 over 2k to the 3rd power, like that. So that would be our simplified version. So in general, if we have x to the power of negative a, then that is equivalent to 1 over x to the a power, like that. Let me just give you another quick example. So if you had 1 over x to the negative a power, like that, then this would, because it's negative in the denominator, if we brought that up to the numerator, it would be equivalent to x to the power of a, like that. So the last exponent rule we want to talk about is the zero exponent rule. And let me just show you a pattern really quick. So let's say I had the number 2 and I raised it to the 3rd power. That is equivalent to 2 times 2 times 2, which is 8. And 2 to the 2nd power is 4. and 2 to the first power is 2. Now, hopefully I'm going to ask you, what is the pattern going from 8 to 4 and 4 to 2? Take a moment to think about what the pattern is to get there. Hopefully you came up with the answer that in order to get from 8 to 4, we're dividing by 2. In order to get from 4 to 2, we're also dividing by 2. So what's to stop us and say that that pattern probably continues if we were to raise 2 to the 0 power? Now, again, if I divided 2 by 2, then the thing that would go here would be 1. So it turns out that when you raise something to the 0 power, it is equivalent to 1. So here I have 7 times x to the 0 power, which is equal to 7 times. We just said that when we raise something to the 0 power, it's equal to 1. So then 7 times 1 just gives us 7. There we go. Okay, so here we're going to have to use the power rule first for w to the 4th power squared divided by w to the 8th power. So to simplify the numerator, we would multiply 4 and 2 to give us w to the 8th power divided by w to the 8th power. And then we would subtract the exponents by using the quotient rule. So there's a couple ways that you can think about this. But if I were to subtract the exponents, 8 minus 8 is 0, so I'd have w to the 0 power, which, we saw that when we raise something to the 0 power, it's going to give us 1. So x to the 0 power is equal to 1.